I hope you all have enjoyed this journey through algebra and calculus. So this is the last lesson, or in the last video for lesson 12, and it's uSubstitution. So what are we actually doing in this lesson? We are going to find the antiderivatives of chain rules. So remember that the derivative using chain rule is, so if we find f prime of x, okay, we can write that a little neater. So if we want to find f prime of x, then that would be 9 times, we leave the inside alone, 4 minus 3x squared plus 4 to the 8th. Now we differentiate the inside, so that's 4x cubed minus 6x. All right? So what do? We had the derivative. So if we have f of g of x prime, then that is f prime of g times g prime of x. So if we want to integrate f prime of g of x, then we have to have the derivative of g of x dx. We have to have this piece there. And what we're going to get is we're going to get capital F, so this is our original function, with g of x inside plus c. So we have to have this g of x, so this is the same thing inside. Okay? Where this is our antiderivative. And this is our original. And this is our derivative. Okay? So now let's go down and look at some. So one of the things that I do, and I do it that's a little bit differently, is that I've given you a list here of how to pick u's, and I want to tell you that these three are going to be used in 3372, and these are for exponentials, so for e to the x and ln. Okay, so those are for ln of x and e to the x. Okay, so we won't actually use those this semester. But there are some things that I do that are now becoming taught more and more, but they weren't for a long time. But this is what I always do, and I always tell you to do it the same way I'm doing it, okay? Even if you find it a little monotonous, but it will help you. All right? So what we're going to do is we're going to let u equal 3x minus 5. So then du equals 3 dx. Normally we would write this as du dx, but now we're going to write the du on one side and the dx on the other. So the next thing you want to do is you want to solve for dx. So you're going to get 1/3 du equals dx. Okay? So now what we're going to do is we're going to just do a substitution game. So we're going to have the integral of u to the 5th times 1/3 du. Now, to make this easier, we're going to move some things around, because remember, this is all multiplication, so we can. So this is going to be the integral of 1/3 u to the 5th du. So now we're going to integrate. So 1/3 is our tag along, and that's going to be u to the 6/6 plus c. So now we're going to go back to our original variable. So u is 3x minus 5 to the 6, and 3 times 6 is 18, plus c. And that's our final answer. That's all there is to it. But we're going to work several more questions just so you can get in the habit of it. Now, here's the thing with derivatives and with integration. The more you work, the more you practice, the better you'll become. Okay? And the more confident you will become. Okay? So, let's do another one. So, u equals 3x plus 7. So, du equals 3 dx. So 1/3 du equals dx. Substitute u to the negative 4 times 1/3 du. Now we're going to rearrange so that we get 1/3 u to the negative 4 du. Now we integrate, equals 1/3 u to the negative 3 over negative 3 plus c, and that's because negative 4 plus 1 equals negative 3. So now we substitute back, so that's 3x plus 7 to the negative 3. I'm going to put our negative sign up at the top, and 3 times 3 is 9 plus c, and that's our final answer. All right? Now, I'm going to do another one. So u equals negative 4x plus 3. Du equals negative 4 dx. Notice that I'm writing the dx every time. So negative 1/4 du equals dx. Substitute. So this is the integral of u to the negative 3rd times negative 1/4 du equals, reorder, negative 1/4 u to the negative 3rd du. Integrate, negative 1/4 u to the negative 2 over negative 2 parentheses plus c. Negative 3 plus 1 equals negative 2. Okay, change back to my original variable. A negative and a negative is a positive. So this becomes negative 4x plus 3 to the negative 2. 4 and 2 is 8 plus c. Okay? Now, let's go here. So I'm going to let u equals ax plus b. So du equals a dx. So 1 over a du equals dx. Substitute. So I have the integral of u to the n times 1 over a du. Reorder. So I have the integral of 1 over a u to the n du. Now I'm going to integrate. So that's 1 over a u to the n plus 1 over n plus 1 plus my c. Substitute. So I have a plus ax plus b to the n plus 1 all over a times n plus 1 plus c. And this is just a general form of the power rule where I have a linear variable, a linear u for u substitution. All right, now I'm going to have something where I don't have a linear, and I'm going to do some reordering before I pick my u. So what I'm going to do first is I'm going to move x over here. So I'm going to have the integral of 8.4 times negative 4x squared plus 5 to the 1/2 times x dx. All right, and I just wanted to reorder some stuff so that I could rewrite it. All right, and you'll see why in a minute. And now I'm going to pick my u. So u equals minus 4x squared plus 5. So du equals minus 8x dx. Now notice that I grouped here. I have x dx. So what I'm going to do is I'm going to solve for negative 1/8 du equals x dx. Okay, now I'm going to substitute. So this equals the integral of 8.4 u to the 1/2 times negative 1/8 du. Now I'm going to reorder, and so I'm going to multiply the negative 1/8 and the 8.4. So I'm going to multiply those two together. So what I get is I get the integral of negative 1.05 u to the 1/2 du. Now I'm going to integrate, so I get negative 1.05 u to the 3/2 over 3/2 plus c. Now I'm going to go back to my original variable. Okay, and over here I'm going to figure out I have negative 1.05 divided by 3/2, and I put that in my calculator, and I came up with negative 0.175. So this is negative 0.175 times negative 4x squared plus 5 to the 3/2 plus c. So that is negative 0.175 square root of negative 4x squared plus 5 cubed plus c. So there is my final answer. All right. So now let's go to our last example. And again, I'm going to say, the more you practice, the better you'll become. So I'm going to let u equal, and how do I know which one of these it's going to be? Well, if I integrate this one, then I don't get this one. But if I take the derivative of this one, so if I let u equal 5x cubed minus 2x plus 1, and I find du, notice I get 15x squared minus 2 dx. Oh, wait. So notice I get that. So then, if I notice that, then what I need to do is I really should reorder this so that I have 5x cubed minus 2x plus 1 to the 5th times 15x squared minus 2 dx. So this right here is going to be du, and this is going to be u. So this now equals the integral of u to the 5th du. When I integrate this, I get u to the 6th over 6 plus c. Going back to my original variable, I get 5x cubed minus 2x plus 1 to the 6th over 6 plus c. So one of the things that you learn